These are the answers for 1.3 bonding questions. So question 1, which of the following contains a coordinate bond? So we have ammonium NH4+, boron trifluoride BF3, sulfur hexafluoride SF6, and water H2O. The answer is A, ammonium. Think of nitrogen, you have 5 electrons around it, and then each hydrogen, and then we have the H plus, so that is a coordinate bond there. Next one, fluorine is the most reactive non-metallic element. It combines with both metals and non-metals. Using dot and cross diagrams, explain how strontium atoms combine with fluorine atoms to form strontium chloride. Show the outer electrons only. So we're going to do strontium first. So outer electrons only, strontium group 2, and then the fluoride ions. So we're going to need to give one of those electrons to each of 2 fluorines. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 electrons around each fluorine atom. So that strontium, of course, is going to give away those 2 electrons, so it'll be 2 plus, and then each fluorine becomes a fluoride ion. So it has its original 7 electrons and an extra electron from the strontium. And each fluoride ion has a negative charge. 4 marks for each of those. If there's one mistake, you take 1 mark off for each mistake, so negative marking in that question. Number 3, sulfur and fluorine combine to form sulfur hexafluoride SF6. Sulfur and fluorine atoms have different electronegativity values and form a polar bond, but sulfur hexafluoride is non-polar. Define the term electronegativity. So this is definitely a definition that you need to know, and I'm just going to put it in for you. So it's the extent to which an atom attracts the bonding electrons in a covalent bond. And remember, be very careful with your definitions because they do like negative marking, see ya. So part 2, label the diagram to show the polarity of the S to F bond. So we know that fluorine is the most electronegative atom, so it's going to be delta minus, and sulfur then delta plus. Okay, number 3, part 3. Draw a dot and cross diagram showing the bonding in SF6 using outer electrons only. So if we look at sulfur, we know that it has 1, 2, 3, 4, 5, 6 electrons, being in group 6. And then we have the fluorines around it. So it's 6 of them, and each of them has 7 electrons. So it's just a matter of drawing all those in. So if I'm right, we should have 8 electrons around each fluorine, and then there are 12 around the sulfur in the middle. And it says, explain whether the SF6 molecule obeys the octet rule. The answer is no. And the reason is because it has 12 electrons in the outer shell. And of course, if it was obeying the octet rule, it would only have 8. And finally, which one of the following is involved in metallic bonding? Is it electron delocalization, electron transitions, gaining electrons to form ions, or sharing electron pairs? Well, we know definitely not sharing electron pairs. Gaining electrons to form ions, well, metals give away electrons to form ions. Electron transitions, they're nonsense in this. So it has to be A, electron delocalization.